And then let's open a new file, a drawing file. Now, you already know how to select the sheet size, and we're going to use an ISO 3 sheet size, and continue. Select assembly cam, next, and let me get a preview and say that I get a front view, top view, right side view, and an isometric view. Escape. And what I'm going to do next is immediately to remove the tangent edges, which you can do it automatically for the current document before you open it. And I'll do the same thing for the isometric view. And I'm going to change the isometric view to shaded with edges, and I'll change the front view to show the hidden lines, and the rest of the related views will do so at parts except the isometric view. Next, I'm going to add annotations, a center line, and select a view to do it quickly. There you go. And if you want to do the same thing for the isometric view, you remove the select view and select the features instead to add the axis. And next I'm going to add a center mark to this one, this hole here, and that'll do. I can do the same thing for this hole as well. There you go. You see the lines are intersecting each other, so maybe you can click this one and shorten it like this so that they don't, interfere with each other, etc. So now next, to be able to represent the parts here, we number the parts, and we use ballooning for that. You can either do auto ballooning, or you can do it one by one. I'll show auto ballooning. It automatically selected the view, but you can also change that by selecting the view before, I think. Auto balloon. There you go. So the ballooning is going to be done on that view. But now I want this view, so I deselect everything by the escape key and auto balloon, and now I can select as well. There you go. These balloons are numbers attached to separate parts. You can attach them to their faces or edges. On faces, well, I'm going to show that later on. You can arrange the placement of these balloons around the part like this, or maybe on top, on side, etc. And you can select a magnetic line so that they are aligned vertically or horizontally. You can create a magnetic line later on as well, which I will show later. We preferably use circular outlines. So, and you can change the size, etc. I'm going to skip these; they're not really important. Usually the balloon, what's inside the balloon is an item number, but you can also use different data to show here, or you can create a custom data, maybe the part number, the item number, dash the part name, description, etc. You can create a equation for that and use it here as well. So I'll just say that's enough. But by the way, ignore multiple instances is usually what we prefer to do, because if you have multiple of the same item, you just say I have this much of that, this many of this item, and note it on the parts list and say OK. Now what we prefer to do here, although this is just the three parts in this assembly, what we prefer to do is to be able to read the numbers as quick as possible. So we prefer to arrange them so that the numbers are aligned in ascending or descending order. So, and the next thing we prefer to do is to align these leader lines so that they are parallel to each other, so that they look like a group, and it's easy to distinguish them from the rest of the drawing. So we prefer these lines to be parallel to each other as much as they can be. We want these to be legible from 1, 2, 3, 4, 5, etc., going around the part as much as you can. It's not necessary. And these have to be preferably inline. So I'm going to do, this is enough for this technical drawing, but I'm going to do the same thing for this isometric view as well. And this time I'm going to use a balloon, separate ballooning. I'll click on the parts and place the balloon. Click on the parts. Be careful, not the axis, the parts. And place it just randomly for now. And click on the parts and place it randomly. Now I'm going to arrange these. Escape. What I'm going to do is maybe I shall arrange them on this side so that I can place it like this, or maybe I'll just keep it here, it doesn't matter. You cannot have it all at the same time. So the connection here, if you place it on an edge, it will turn out to be a arrow. If you place it on a surface, it's going to return back to a dot. If I place it on this part, it's going to change its number, so it's flexible. So I'll place it here, although this is not a good place to represent. I'll move it down a little bit, move this one down a little bit, and place this one a little bit higher, and so that they look parallel. And what I'm going to do next is to align these in lines. So I'll use a magnetic line for that. I'll draw a line here. The length of the line is important here, because it's going to adjust the positions of these, the numbers on it, according to its length, rational in ratio. We usually would prefer to make it a free drag, but you can separate it into equal points. So when I say equal, it's going to deliver 1, 3, 2 equally on this line. So that's something I don't want. And so you can adjust the length. Usually we want it to be like 90 degrees, 0 degrees, etc. So next I'm going to click on this number and place it on the magnet line. And that's it. Now I can move them together. And if I drag it, they're going to be stretched according to the same ratio. So this is how it works. These are the BOM numbers.